Multicore processors are now found in almost all computing devices, from mobile phones to the largest supercomputers, creating new possibilities and new challenges for programmers. KTH professor Mats Brorsson teaches a course in programming multicore systems, offered to KTH students, and as a commissioned course for industry. Here, he talks about why multicore processors have become ubiquitous and what participants will learn in the course. Tell us about yourself and your background.
Well, I'm a farming boy from the beginning, but professionally I have an electrical engineering master's from Lund University. This is where I learned how to build and program computers, and I followed up with a PhD in computer engineering from the same university.
Why did manufacturers go over to multi-core processing instead of just continuing to raise the clock frequency? That had been working very well for years.
Yes, it had. That was very, very convenient for programmers because they could just continue writing the software, and relying on the next generation of processors would improve the performance. Well, the reason for going multi-core was pure physics. The main reason was clock frequencies. Clock frequency increasement led to thermal problems. The chips became too hot.
It seems like the whole computer industry went over to multi-core processing in a very short time. How did that happen?
That's right. They all faced the same problem. In embedded systems, they have been using multi-core processors for various reasons quite some time. Mainly because either they needed the consolidation or they needed it for performance reasons with low power consumption. But in server and desktop area, that all happened within a couple of years. All the big manufacturers, Intel, AMD, Sun at the time, now Oracle, IBM, they all went to multi-core as the main products, and it happened within 2 years of each other because of the same thermal limits.
They all ran into the same physics at the same time.
Yeah,
obviously.
IBM is a little bit of a counterexample because, well, they have also gone into multi-core, but they are also the world leader in terms of cooling technology. They have liquid-cooled chips and things like that, so they can push the clock frequencies higher than anyone else.
Now, what does a programmer need to know to make use of the possibilities of multi-core processing?
Previously, programmers could just leave the code as it was, and then the next generation of processors would naturally give a performance improvement. This is not possible with multi-cores because now the individual cores, they are not faster by every generation. Instead, you have more cores. So you need actually to parallelize your code. You need to make it parallel, and that is pretty difficult thing to do for most programmers. And this is sort of why this course is necessary, because we deal with things like how to parallelize the code more easily.
Why not just run multiple applications in parallel?
Yeah, that's certainly a possibility, and that is actually in embedded systems still the most use of multi-core processors. There are some severe problems with that in some cases, however. Some applications, they don't really go well together because on a chip, these cores share resources. They share memory interfaces, they share cache memories and things like that. A lot of resources are shared. And if you have multiple applications running at the same time or multiple single-thread programs, they will interfere with each other. And in real-time systems and things where timing is important, this can be a major problem.
What are the challenges that a programmer faces in going over to multi-core programming?
Well, the main challenge is that it's pretty difficult, sort of in general, to partition your program, to partition your problem. You need to think about data structures, how are data partitioned between the cores. You need to think about communication, how should the cores communicate, and you need to think about scalability. And all these things are sort of, well, parallelism is sort of a natural way of thinking of humans, but it can be quite difficult with years and years of education in programming where we didn't use parallelism.
What does a programmer need to know about multi-core architectures to begin writing software?
To write the best performing software, all programmers should know quite a bit about architecture. You need to utilize the memory structures on the chip the best way possible. And with multi-core processors, this only becomes more important. you have more kind of structures to think about how they interact and so on. So the more you know, the better performing software you can write.
What are heterogeneous parallel architectures, and why is that concept important in multicore processing?
So this is pretty recent development that multi-core processors also are heterogeneous. There are many ways in introducing heterogeneity. For instance, you can have data parallel accelerations like vector units and things like that. But what most people mean by heterogeneous processing is the use of GPUs for general purpose processing. So GPUs was introduced to accelerate the graphics, mainly for games. But it turns out that the hardware needed for that can be utilized for data parallel execution of general kind. It makes the programming even more difficult, but it's important in order to get the best performance PowerPoints for certain software.
Why don't we have compilers that can automatically parallelize programming and make it easier on the programmer?
It's been tried for a long time, and if you ask compiler vendors, they will say they will tell you that you can buy one of those. For certain problems, it's certainly possible, but the problem is that programming languages in general are so unspecific of how data is used, so compilers have to be very conservative in how they parallelize things, making it more or less useless for automatic parallelization. So you need a human brain to actually tell what goes where in the parallel computer.
Tell us about this course now. What will the people who take this course know by the time they're done?
So we will introduce the basics of what they need in computer architecture, in particular when it comes to parallel and multi-core architectures. We will deal quite a bit with parallel programming models that are of a higher abstraction level. The higher abstraction level is important to allow more programmers to do this more conveniently. There's been parallel programming going on for a long time, which requires quite a bit of performance tuning. But with the new parallel programming models that raises the abstraction level, we can do this more easily, and we will talk about these. And the third thing is about tool support. We'll go over the tools, some state-of-the-art tools that help programmers do this with good information on what they are writing for.
Mats Persson, thank you very much.
Thank you.